Welcome, everybody. Hi. Is that Lawrence? I don't know if that is. Never mind. Hi, everybody. Hi, John. Good morning. Or, yeah, still morning. It still counts. Goodness, I am so glad to be here. Look at all of us. We're here in Devnexus. 20 years. I can't believe it. I just blew in last night, and I'm just super happy to be here. I can't believe we all get to be here. Who's had a good? How was the show? Was it great or the greatest? The greatest. That's the right answer. Okay, good stuff. Well, look, I'm just super happy we're all here. Thanks for coming. My name is Josh Long. I work on the, here, full screen. Very important to give the slides the due reverence and respect that they're entitled. My name is Josh Long. I work on the Spring team as a Spring developer advocate. I am a Kotlin Google developer expert and a Java champion and a YouTuber, which is super cringe. But it's true. So there's that. And there's code. You know, we're going to look at a lot of code today, as always. That code is here on the internet, should you deign to consult it. And email. I'm on email. Who's using email? Anybody? Anybody using email? No. Good. Moving on. There's that. I'm on Twitter and X. On Twitter, I would tweet. On X, I would excrete. That's the right answer. Exactly. I don't know I don't know, whatever. I'm there. If you are mistakenly also there, you can find me there. My friends, look, I'm just, we're here. It's 20 years of Devnexus, and it's a long enough stretch of time that you can kind of appreciate the totality of it all. You know, you can think about what happened 20 years ago, you know. And indeed, I think about just the stretch of time in which we find ourselves and the time leading up to it a lot. I think about it a lot because, honestly, there's just never been a better time to be a Java and Spring developer. And I say that fully aware, like I say, fully aware of where we've come, right? How many of you have seen this wonderful thing? This is a thing that we did in anticipation of the 20th anniversary last year of the early access builds of Spring Framework and the 10th anniversary of the early access builds of Spring Boot. We celebrated that last year. So this is spring1.io/history of Spring. And you can play the game if you want. Just see the history, right? So Rod Johnson publishes the book addressing J2E complexities back in 2002. So the earliest bits of code that would then become Spring Framework, that would then eventually look like what we know as today as Spring Framework, that was conceived in 2001 and then eventually published in 2002. We have, 2003, Rod and Jürgen and others start the Spring Framework open source project. We've got the Spring Framework 1.0 released in 2004. So GA is this year. 20 years GA since 1.0 Spring Framework, and 10 years GA since 1.0 Spring Boot, right? That's this year. We celebrated both of them. It's like March 25th or whatever, and then April 1st, which is a little awkward given the holiday. But that's April 1st is the 10-year anniversary of Spring Boot, right? And by the way, I had on the old Spring YouTube channel, Spring Source Dev, I have a nice discussion with Rod Johnson, who's the first person to ever work on Spring, and then Jürgen Holler, the second person, and they both came back for an interview. Well, Jürgen is still very much involved, but they came and sat for an interview about the sort of, Spring at 20 years. It's just what a weird thing to think about, you know? So Spring Framework 1.0 released 2004, Spring Security 2.0, with a CG, Spring Data 2011. We get Spring Boot 1.0 released 2014, Spring Batch 3.0, Spring Integration in 2014 enables integration flows without XML. Now we're in the clouds. I know this is subtle. We're in the cloud, so Spring Cloud 1.0 released 2015. Spring Cloud Task, introducing support for short-lived microservices 2016, Spring Cloud Stream 2016, Spring Cloud Data Flow, right? Going back down in the water now, maritime themes, Kubernetes, okay? I mean, subtlety is not a developer's strong point. Spring Cloud Data Flow for Kubernetes 1.0 orchestrates long-running and short-lived data microservices and Kubernetes. Spring Cloud Skipper, right? And then, of course, 2022 gets us to the current era, right? Which is Spring, that's 2021. Moving forward. Onward, Spring Boot, there you go. Spring Boot 3.0 and Spring Framework 6 enable natively compiled applications to run more efficiently in environments like Kubernetes via GraalVM. And then, of course, you find that we can celebrate 20 years. It's an amazing, amazing time. I think about that a lot. That's what I'm trying to say is 20 years since the very first 1.0 GA release of Spring Framework, 20 years of Devnexus. Coincidence? Yes. Yes, it is. But really nice coincidence. So an amazing time to be alive, an amazing, amazing moment in the sun. And the reason I think about this all the time, the reason I say that there's never been a better time to be a Java and Spring developer is that even against the backdrop of all those 20 plus odd years of evolution and innovation and all that, I think right now is the absolute most interesting time to do what we're doing. There are more opportunities for us using Java or using the JVM or using our skills honed on the JVM than ever before. And my friends, as always, to demonstrate that, we're going to go to my second favorite place on the internet. Can you guess what my first favorite place on the internet is? Thank you. Production. Thank you. Thank you. My second favorite place, of course, is start.spring.io. We're going to build a brand new application, and we have some choices we have to make, friends. First of all, what build tool do you want to use? I don't care. It doesn't matter. Either one of them is fine. You have to choose also what you want to call your service. Well, friends, I'm going to call my service service. And the reason is because I'm amazing with names. Really, really good with names. I got that from my father. My father was also really amazing with names. When I was a small boy, we had a small white dog, and my father named him White Dog. Amazing, amazing with names. That said, my mom, she tells me all the time, she says, "You're very lucky that I named you." And yeah, that's probably true. So anyway, we're going to call it service. And then, my friends, we have a choice about what version of Java we'd like to use. And obviously, friends, you don't see Java 8 here. There's a reason. First of all, we don't support Java 8 in any modern supported version of Java, right? So of Spring Boot. You've seen the Spring, projects.spring.io, Spring Boot, right? Here, and then you go to support, and you can see the support window for a given open source release of Spring, right? If you go to any of these project pages, you'll see the support lifetime for open source and then commercial and then not at all, right? So if you're using open source, there is no version of Spring Boot out right now that supports Java 8 in open source support, okay? Only commercial support, and even there, the window is fast closing, right? So we have 3 choices here, really, right? Java 17, 21, and 22. Look, you can use 21 or you can use 22. You've got a bunch of choices here. Anything above 21 is great. Remember, Java 21 is technically superior in every way. It's more efficient, more robust, more secure, more performant, more operations friendly, and of course, it's also morally superior. You won't like the look of sadness and shame in your children's eyes when they find out that you're using Java 8 in production. Don't do this. Be the change you want to see in the world. Do the right thing. Use at least Java 21 or later. Now, friends, I'm going to use Java 21 because it doesn't, at this point, it's all gravy. But Java 21 is an absolute must baseline. You must be using Java 21. To do anything less today when you have the opportunity is software malpractice. It is truly what Oracle and the OpenJDK community have done in Java 21 is nothing short of magic. I couldn't be more grateful and more thankful for what they've done here. And we'll talk about what I mean by that in just a second. Then we have some decisions to make. What do we want to have? Well, I'm going to build a web application, surely. I'm going to need a Postgres database, okay, sure. I'm going to use Spring Data JDBC, fine. I'm going to use the GraalVM native image support, okay. I want a Docker Compose file, fantastic. And of course, it's 2024. Where would we be without some AI? So I'll add some of that as well using the Spring AI project. All right, so we've got our normal stuff here. Spring Data JDBC, a SQL database, a Docker Compose file to start up that SQL database, a web framework, and our Spring AI project. Let's go ahead and hit generate, and we'll open this up in the IDE. So here we are, UAO service.zip. Okay, open this up. Okay, so this is a brand new public static void main, sort of application. Unsupported. Oh, I'm using Java 22 on my local machine, and Gradle. Gradle. Okay, well, you know what? I can fix this. Here we are. Easy. Easy button. Okay, here we go. Service. Okay, make that much bigger. Actually, Zoom. Oh, oh, there we go. Come on. You know what? You know why I'm all out of practice here? I just did a keynote for Google Cloud Next in Vegas yesterday, and they were using Linux. So now my keyboard foo is not as strong. Okay, so let's see. 110, very good. Okay, so public static void main, here's our application. It's gonna be a data-centric application, and to that end, I need a database, surely, right? So because the Spring Initializer is awesome, it generated a Docker Compose file for me here, and it put it in the project. So I'm gonna go ahead and expose this port, and then, frankly, I don't wanna, what will happen by default is if you leave that in there, and this is fine, it'll actually restart that Docker Compose image for you on every single restart, which is fine, but in our case, I just want to go ahead and I'll do it myself. So Docker Compose up, let that do its thing. Maybe I already have a Postgres instance running. Who knows? We'll see. Here we go. Take your time, really. It's okay. Nobody's waiting. Okay, good. Good. All right, so there's our application. We've got our application up and running. I want to build a data-centric application, friends. What am I going to do? I'm going to start with an entity, right? I'll build an entity here like this to describe the data. We're going to have an entity of type customer. It's going to have a primary key. I'm using Spring Data JDBC. I love Java records. How many of you are using Java records? Java records are amazing. I love, love, love Java records. Okay, it's just amazing. And don't sleep on what I've just done here, friends. I've just used this to create a simple entity, but make no mistake, this unlocks a number of different features that if you take them all together, support what the Java language team is calling data-oriented programming. Okay, how many of you have heard about this? Data-oriented programming. And the idea, the core conceit here is that Java has historically dominated in the world of the monolith, right? And monoliths, it's done very well because it's got fast compile times, it's got good privacy controls, it's got a good compiler, good type safety. It's very easy to build a large sprawling code base with Java because you can. Is that me? Who would message me? I don't have friends. Let's see here. Okay, there we are. Sorry about that. All right, so Java is a application framework that, it's a language that has been very natural in the world of the monolith. It's obviously very successful because it's fast, it has privacy controls and type safety and so on. And in that deep, in that world of large sprawling code bases, deep-seated hierarchies of abstractions with specializations are how you communicate change in the system, right? You want to add a new feature? Specialize. Create a new implementation of something, right? An abstract type, and then implement that. And this is a natural thing to do in a large code base. But increasingly today, we're not building large, sprawling, monolithic code bases, are we? We're building small, data-driven, ad hoc sort of microservices, right? And in this world, the vector of change is no longer the specializations of particular hierarchies, but the messages that you send across the system, across the boundaries, the network boundaries and so on, the service boundaries. And in that world, the language needs to change a little bit. It needs to be a little bit more adept. And so it sprouted a number of features over the last several releases that culminate in Java 21, including records, which we've just seen briefly, sealed types, pattern matching, right? And of course, smart switch expressions, okay? And these things taken together support this new paradigm. And let's take a simple example, okay? Let's suppose I worked in a highly regulated industry, okay? That's not me, is it? Can't be me. I just turned off everything. You can just turn off the phone. There, power off. There's no way that's going to bother us. Ding, no. Let's see. Let me see. Okay, so let's imagine I'm working in a highly regulated industry, and I've got a loan, okay? Like a bank or something like that, right? Loans are highly regulated financial instruments in most jurisdictions. I say most because there's obviously Wall Street. But we have a loan, and a loan is a thing that there's laws that have to apply here. So let's say I want to build an implementation of that. Secured loan implements loan, right? Okay, good. And unsecured loan implements loan. All right, so I've got two implementations of this type, but remember, highly regulated financial instrument. The last thing you want is somebody creating an anonymous inter-class implementation of this and sidestepping all the validation that was put in place to make sure that we're doing things by the book. Sam Bankman-Fried, right? We want to make sure that we're not skipping any unit tests and we're not sidestepping any validation here. So you want to make sure that when you have two types of loans in the system, that you handle all of them and that you know what's being done, okay? So I want to seal this type. I'm going to make this a sealed type, which means I'm going to, in a more granular fashion, limit what is allowed to be created and not allowed to be created in the system, right? I'm only going to permit these two particular implementations. This is more granular than private or public, right? It's not foreclosing on all implementations outside of the package or whatever. It's explicitly sort of enumerating those that are allowed. Okay, so I'm permitting two, but it's still complaining. Why? Well, that's because these haven't been made either final or haven't been resealed, right? So I'm going to make them final. And now the compiler knows exactly that there are these two implementations. Okay, fine. Well, what about this? Well, you know, this has some state, but it's not very interesting state. So for the moment, let's turn this into a record, okay? And records are another wonderful feature in Java. What they are, the compromise that you make when you use records is you're saying, hey, this is a tuple. This thing that I'm defining right now is a tuple. It's a carrier for typed data in a particular sequence. But in Java, everything has a name. It's a nominal language. And so we say that records are, records are tuples, but they have names, okay? So that's why we have these things. But if you agree this contract, if you say, yes, I agree that the data in this record is equal to the components, these things I'm passing in here, then you get some interesting concessions you can make. The Java language is saying, hey, the value, the identity of the unsecured loan is equal to the identity of the float that we pass in. If I want to recreate that loan, I just have to pass in that interest again, right? And similarly, if I want to extract out the essence of that unsecured loan, I can just extract out that float value, store it into a disk, and then create another one somewhere else, and it's the same exact object semantically, right? If you agree that contract, then the language can do some very interesting things for us. It can create storage for that constructor argument. It can create a constructor. It can create toString equals hash code. It can create all that stuff. It can create getter methods for all the fields in the record as well, right? But it only works if you agree that there's no derived state, right? Data in, data out. That's a carrier for typed data. That's it, okay? If you agree with that, though, the language can do you some really nice solids. Okay, so we've got a record, which is a loan, and you've got a secured loan, which is a loan, okay? Now, let's say I want to create let's say a loans service or something like that, and I want to create a message, display message for loan, passing in the loan, right? Okay, and let's say var message equals, there we go, and I'm going to return message, okay? And what am I going to do? I'm going to say, okay, well, if loan, instance of secured loan, right? Okay, var sl, I'm going to downcast, okay, to the loan, and I'll say, okay, message equals, you got a secured loan. Nice. Okay, very, very friendly message. What about over here? Okay, if loan, instance of unsecured loan. Okay, var usl equals unsecured loan. Ho, ho, ho. Typing at an angle. Okay, loan. And then we say message equals ouch. And very user hostile message at this point, right? Okay, so usl dot oops, come on, go back. Interest rate is going to hurt, right? Very, very on the nose. Okay, good. So now I'm returning a message given each type of loan. I'm handling both cases. You and I both know that, but that's all. We are the only ones that know that. The compiler does not know that. If I comment this out, nothing happens. Also, this is very verbose, right? I've got this extra code here. What if I could make this a little bit more concise, right? So one thing we could do is we could start using pattern matching. Here, I've already matched a pattern. I just haven't done anything with a match. I can actually extract out the result of this match into a variable, like that. And within the context of that if, that SL is valid. I can dereference the thing that I'm casting. So I can do that. But actually, I can go a step further. Remember, unsecured loan has an interest. And actually, that's all I really care about here is the interest rate, right? So I can actually match out the component. I can extract out the component itself into its own variable. And in the context of this string, that's a float, right? I'm extracting out the identity of the component, from its component parts, okay? Okay, so now I've got this. This is still good, but again, what happens if I do that? Nothing. The compiler doesn't care. I've gained nothing from this exercise. Somebody could comment that out and ship it and no tests would break. Well, maybe no tests would break, right? I haven't made sure that I'm covering both cases. So let's see if I can make this a little bit nicer. We can do smart switch expressions, okay? So I'm going to do a switch expression. I'll say case unsecured loan. Same here, I'll do var interest. And I'll take this string, okay? So here we go. Good. And what about the secured loan? Okay. And I'll take that value here. Good, and put that in there. All right, so now I've got a smart switch expression. And actually, I can just remove this intermediate variable now, right? Oh, IntelliJ has gotten a bug. Let's see, return. There we are. Look at that. And so now if I comment out one of these branches, what happens? Oh, the compiler says, hey, you forgot to cover a case. So the compiler is making sure not only that I cover both cases, so I get better, more reliable, more trustworthy code, but it's also more concise because the smart switch expression is returning an expression, right? The product of each branch is an expression that gets returned from the return method. So this is very, very convenient. So I've got records, I've got smart switch expressions, I've got pattern matching, and I've got pattern matching and records and sealed types. All these things taken together support data-oriented programming. So when you see me doing this little thing with the record here for the customer, just know that that unlocks a million other things. Okay, I've just begun to hint at the possibilities there. Let's just ignore that and move on though. So we've got this customer, right? Basic, simple customer. And I'm going to create a repository here, interface, customer repository. Extends a list of CRUD repository, managing entities of type customer whose primary key is of type integer. And I want a simple HTTP controller, customer HTTP controller, like so. I'll inject the customer repository, voila. And I'm going to create a simple endpoint here. Customers, customer, turn this dot repository at find all. All righty, now, and there's my simple HTTP controller, okay? Now, of course, I'm going to be making a HTTP request and then talking to a SQL database, and that database is going to do what? Absolutely nothing. I have no data in the database. Obviously, it's going to fail. So let's fix that here. I'm going to go back to source main resources. I'll create a new file here called schema.sql. And here I'll say create table if not exists customer ID serial primary key name text not null. Okay, and I'm going to create some sample data as well. So data.sql, and I'll say delete from customer. And then I'll say insert into customer, name, values. And we're going to put some people on the Spring team. Hi, my name is Josh. Nice to meet you. Some others as well. Good, good, good. Let's see. I'm thinking about this. Oh, of course. In no particular order, by the way. There we go. So we got some people on the Spring team there. That is what? That is 8 records. Good. That's a nice round number. I can divide it by 2 and then 2 again. Makes me happy. Okay, so finally I want to tell Spring Boot to connect to the SQL database. So I'll say Spring data source, here we go, username. And the user is my user. And then the password is secret. And then the URL is JDBC :postgres QL :localhost my database, I think, right? Is that what we said? Docker compose my database secret my user, my database secret and my user. Good. Okay, and then finally I want to tell Spring Boot to initialize the database. Okay, so let's do that. I'm going to go ahead and start the application for the very first time, and we'll go to the browser here, localhost 8080/customers. Voila, it worked. Of course it worked. It was a demo. It was always going to work. So anyway, we have data in the database. Great, fancy, not surprising. You've seen this before. It's 2024. You could have done this 10 years ago, albeit with much less panache. So we have an application talking to the database, a web app babysitting a database, to use the old Ruby on Rails nomenclature. Now what? Well, it's 2024. This is interesting, but we're not nearly where we should be. It's obviously, we have AI now, right? AI is a new paradigm, and Spring always meets you where you are. It meets us where we are, so we can serve the new use cases, to cater to the new use cases. And we've always done that. We've got Spring Security for security, you got Spring Batch for batch processing, Spring Integration for integration. You got all these different projects that support different use cases. And right now, one of the things that I think most is deserving of some help is the world of AI, right? Because clearly the search for regular intelligence wasn't hard enough. So we have this project called Spring AI. The purpose of it, the sort of motive behind it, is to support the whole RAG pipeline, right? So you think about what happens in the world of AI. You have you've all probably used something like ChatGPT, right? Something like a chatbot that you can use. That in turn is powered by an LLM, a large language model behind the scenes. That LLM can answer questions, and you can send it, generic free-form text queries and all that. But that's just the beginning. The question then is, okay, I've got, let's say, a dozen different LLMs out there, and there are innumerable many of them, right? And Spring AI supports all of those. We have an abstraction that lets you talk to all of them in a consistent way, okay? But going beyond that, let's say I have an LLM. Most LLMs have a sort of a best buy date, an expiry date, a best open before date, right? After which their data is stale. They don't have any updated context to answer your questions, right? And even if they were as up to date as they possibly could, they're still not going to know everything. They're not going to know what's hidden in your SQL database, deep in your, the IT department of some organization or whatever. So the question then is, how can I integrate this LLM and this AI with my application and do so in such a way that it is informed by the data in our database, in our systems? So this is the whole RAG pipeline, retrieval augmented generation. The idea is you're going to, as easily as you can, take data, store it in such a way that it can be searched for similarity. That's called a vector database, right? And Spring AI supports a number of different vector databases, all the popular ones, certainly. And then you want to use that vector database to inform queries that you then send to the AI. So that way, when the user makes a request to the AI, you can say, hey, this is the user's bank account, for example. Imagine you have an IVR for the user's bank system. Here's the user's account balances. The user's name is blah, blah, blah. And when they ask questions about anything related to this, please keep this information in mind. And then the AI can provide responses sort of catered to that, right? Informing that response is everything. That whole pipeline is the purview of Spring AI. So we don't have time to cover all of that, but it is pretty simple to get started. So let's go ahead and build a simple controller here, okay? Here we are. We're going to say at controller at response body class story controller, private final. And we're going to use the chat client. Okay, I'm going to call it singularity. There we go. Inject that. Create an endpoint here. Story map string story time. Okay. Turn map.of story, and we'll provide a response. So var prompt. Okay, I'm going to provide a prompt. Yet another great use for multi-line strings in Java. I love this. It's not just for SQL. Okay, and then response equals this dot singularity dot call, passing in the prompt, and then pass this here. Okay, response. Voila. Now, what are we going to say in the prompt? And by the way, for this to work, by the way, remember I have on the in the build here the Spring AI OpenAI Spring Boot starter. In order for this to work, I need to authenticate, obviously. So I'll say OpenAI, and I'll pass in the API key. I've already done this off screen, friends. In my own machine, in my own time, I've already exported an environment variable of that form before I got on stage. So you'll forgive me for not leaking my API credential. Just trust me, it's there already, okay? So now I'm going to go here and write a prompt, a query. So, dear singularity. And it's important to be polite, remember? They will remember. Yep, there we go. Singularity. That's right. No, it's not. Oh, there. That was weird. I would have had to backtrack and start all over again, like the whole talk. Okay. Please write a story about the lovely Java and Spring Boot developers in the amazing city of Atlanta, Georgia. Please incorporate elements about the food, culture, and weather. And please write it in the style of famed children's author, Dr. Seuss. cordially, Josh. Okay? It's very important to be polite. And again, this is one of my favorite doctors, along with Doctor Who, Dr. Strange, Dr. Sire, Dr. Subramaniam, Dr. DeVolder, Dr. Pollock, etc. Dr. Pollock, by the way, is the lead of Spring AI. Okay, so we're going to go here. Story time, okay? Hit that endpoint, drink some water, wait for it, wait for it. Oh, worth it. All right. So, in the city of Atlanta, Georgia, where the sun shines bright, live Java and Spring Boot developers. Oh, what a sight. They coded and programmed from morning till night, creating apps that shone with a digital light. In the land of peaches and southern charm, they work with precision and skill on their farm. I didn't know that. What farm? Okay, presumptuous, but I appreciate where they're going. Their code was clean and their algorithm strong. They were the best developers all along. Okay, you get the point. It can write poetry. It can do amazing things. We have finally arrived, okay? But there is a problem. It did take a long time, didn't it? I had time to take a swig of water. Don't get me wrong. I couldn't do it any faster. I'm not begrudging it that time. I just want to say, objectively, it took longer than perhaps I would have expected from a normal API response, right? And that's fine, actually. Again, I don't begrudge it that time. I could not have done a better job myself personally, and so I'm happy with that result. But I do have questions about the implications for the scalability of our system. Imagine that, right? Think about what's normally happening in a service. You make a request, there's a thread per request model. I make the request, it gets sent into the servlet container. The servlet container assigns a thread. That thread then invokes my servlet, which is the dispatcher servlet. The Spring MVC dispatcher servlet then invokes my controller handler method, which is the method that has the @get mapping annotation, and then that in turn calls OpenAI somewhere behind the scenes, doesn't it? All the while, what's happening there? I'm making a network call to another service, and I'm getting back an input stream, and I'm calling input stream.read. When I call input stream.read, deep in the bowels of that OpenAI implementation of chat client, there's a call to input stream.read, right? That, the URL connection or something like that, right? There's I/O happening. Well, that I/O is blocking, right? We're sitting there waiting for the next byte, but we're not getting it, right? I mean, you've all written this kind of code before, right? If you look at over here, let's just take that I/O, okay? So you've seen something like this. You've got an input stream, right? New file, input stream, foo, whatever, throws exception, okay? And so I'll say try, and then var next equals -1, while next equals input stream.read, okay? Does not equal -1, and then I'm gonna accumulate the next byte, right? Very simple I/O. We've all written this kind of code from forever. What's happening here? I'm calling input stream.read. I'm on line 24. I don't get that next byte until that byte arrives. I don't get to move on in that code until that byte arrives. If that service is down, that thing will never arrive, and that means I'm stuck here waiting on line 24. What's stuck here? A thread is stuck here. Nobody else in the system can use that thread. And this isn't such a big deal, except that threads are expensive historically, right? And so we've all sort of sought for ways to sort of make use of that thread without actually blocking it, right? We have things like non-blocking I/O, right? Very, very, very useful idiom that was introduced in Java 1.4 and then 1.6 and 1.7. That support is pretty good, but again, it's low level. Most of us don't think about the world in terms of byte buffers and sockets and that kind of thing anyway. So we want to move up the abstraction stack. And so here, for good reason, the community introduced something like reactive programming. And I like reactive programming, but it's moot, isn't it? First of all, we don't have a reactive API here. And second of all, some people don't want to do reactive programming, right? They don't want to think that way. It's a different way of thinking about how you write your code. If you're coming from Lisp or a more functional language, I think reactive programming will feel very natural. But if you're just doing this kind of stuff, and why wouldn't you? Then it's going to feel maybe a little different. So the question then is, how can I have my reactive cake and eat it too, right? How can I repurpose that thread while I'm waiting for that next byte? How can I make that thread available for other things in the system? And this is where Java 21 comes in real clutch, right? Java 21 has a new feature called the virtual threads. To demonstrate this, I'm going to show you an example that I'm stealing shamelessly from my friend José Pomar, the Java developer advocate over at Oracle. And very simple example, okay? To demonstrate the magic of virtual threads in action. I'm going to create 1,000, and by the way, seriously, if you, merci José Beaumer, okay? Okay, so for var I equals 0, I is less than 1,000, I plus plus, threads, I'm going to create a new thread, so var t equals thread, and I'm going to create the old kind of threads, the kind of threads with which you are no doubt familiar from Java 1 and onward, okay? I've got 1,000 threads. I'm going to add that to the collection here, threads.add t, okay? And then for each thread that I've just created, I'm going to start it, and then I'm going to wait for it to complete. So I'm going to join it, okay? So there we go. I've got now 1,000 threads. What am I doing in those threads? Well, in those threads, I'm going to take note of the current thread name, and I'm going to add it to a set. Sets are deduping collections. That is to say, if I add the same element 5 different times to a set, I can only iterate it on it once, right? It gets deduped by definition. So I'm going to take note of the current thread name, okay? So, but I'm only going to do it for the very first of the 1,000 threads. So I've got 1,000 threads. I'm creating a lot of load, but I only want to monitor the flow, the name of the thread for one of those threads. So I'll say if we're in the first thread, then names dot add thread.currentThread.toString, okay? And then we're going to sleep. So this is a blocking operation as well. This is just like input stream.read. I don't get to move to line 44 until I'm done sleeping. Simple as that. And in the meantime, I'm sitting on this thread, okay? So I'm adding the name to the set if I'm on the first one, and then no matter which thread I'm on, I'm sleeping for 100 milliseconds. Now I'm going to paste this 3 more times. Okay, so I'm sleeping for a totality of 400 milliseconds across each of those 1,000 threads. Okay, and there we go. So let's go ahead and print out now the names when we run the program. So I'll go ahead and restart the program here. And when the program starts up, yes, it's exactly what you would expect, right? Physics have held. The world is as we expect. If I walk down Market Street and I go 5 meters, and I'm on Market Street, guess what? I'm still on Market Street. That's how the world works, right? Like, if you don't just change streets if you're on the same street. That's the whole point. But in Java 21, they have added a new thing called virtual threads. And they've disconnected the reality of our actual threads from the operating system threads underneath it, right? Right now, in this model, using a platform thread, there's a one-to-one connection between operating system threads and Java lang threads. Those Java lang threads and operating system threads, they live and die together. They broke that connection in Java 21, okay? They introduced a new thing called a virtual thread. So here's this. I'm going to go back. I'm going to change this to be virtual. That's all I've done, okay? I'm going to restart this. And there's my program. And there's the thread. So logically, right? And again, remember, I took the name 4 different times, but it's a deduping set, right? That's why it was added 4 different times before. But there's only one thread name, so it was only added once. Now I've got 4 different unique threads. Logically, I'm on virtual thread 74, virtual thread 74, virtual thread 74, and virtual thread 74. But the actual operating system thread is different now, without me doing anything. The runtime saw that I'm doing a blocking operation like thread.sleep, or input stream.read, or output stream.write, and it says, oh, hey, you're not using that thread right now. Let me set an egg timer. I'll take that thread back from you. I'll put you over here in RAM. And when you're done, when the thing that we're waiting for is done, I'll put you back on another thread. But in the meantime, yoink, that thread is mine, right? This is an amazing, amazing result. This thread, this means that now I'm not wasting time on threads. I can do blocking things with impunity. I can call that OpenAI endpoint all I want with no shame or fear, because it's not imperiling the overall scalability of my system. And what did I have to do to get this incredible scalability, this reactive-like scalability, this non-blocking I/O-like scalability? All I had to do was change the constructor. But even still, that's a little low level. Most of us aren't writing code like that, right? You might move up a little bit. Maybe use an executor service. So here you can say executors.new virtual thread per task executor. This is not a thread pool. It's just a factory for threads. It'll create brand new threads ad infinitum, because who cares? You can create millions and millions of virtual threads now for free. It costs nothing, basically, right? There's no reason to fear now. It doesn't correspond to 2 megabytes of RAM associated with each operating system thread anymore. This is a big deal. Okay, great. So I like this. I like this quite a lot. But even here, I have to plug this in to all the places that expect a thread pool or an executor. Well, let Spring Boot do that for you. In Spring Boot 3.2, which I'm assuming you're all using now, you can just do that. Spring.threads.virtual.enabled, and we'll plug it in for you. So now, whenever you're making an HTTP request, or you're doing data processing or batch processing or whatever, wherever it makes sense, we've plugged in that virtual thread executor for you. So what I recommend you do, my friends, is talk to your management. Say, look, I have an idea to increase scalability of our services many-fold. It's going to take weeks. And whatever money we get on cloud infrastructure spend recouped, I want that in my next paycheck. Just let me know if it works. Okay? And then you just set this property. Like just an amazing, amazing result. An amazing result. I could not be more grateful for the Java team for this. This is why when I say if you're not using this and you could, you're failing at software. You should be using this. The Java 21 is an amazing result. This is free money that they have given us. Absolutely amazing. Okay? And we've done benchmarking, by the way. It's like internally we've done some benchmarking. It's like in terms of scalability, it's almost up there with reactive. It's that good, right? It's that good. And I had to do almost nothing to get that result. So thank you for that, Oracle. Okay, and OpenJDK in the Java community. Okay, so now we got the freaking singularity. We've got scalability, like you would get with async await or Go. By the way, this is you know how rare this is? It is so rare for us to be able to say that we have something that is not just as good as other languages, but in this case, we're doing way better. This is so rare. Enjoy it while we can, fellow Java fans. This isn't going to last. But have you tried doing what I just did here in other languages, right? In other languages, they have something like async await, right? Or in Kotlin, they have suspend functions. Async await requires you to paint all your code with async await. If you want the compiler to automatically to create a continuation for your call stack after the blocking thing has happened, you have to paint the function that does the asynchronous thing with async, and then to trigger that invocation, you have to say await the async result, right? And you end up having to paint all your code with these 2 new keywords. It's very, very invasive and ugly and verbose. We don't have that. We skipped past all that nonsense. This is the much better result. We get the same effect without having to change millions of lines of code, or even 1 line of code, right? It's very rare you can say that Java is not just doing as good as other languages, it's much, much better. The only other language I can think of that does something like this is Go, right? And Go had the benefit of starting from the very get-go with this feature. They had Go routines. They built the language from brand new with this in mind. What Java has done here is done it in such a way that every application ever written can upgrade, switch this one little factory method, and then be a part of this new innovation. Just an amazing, amazing result. Okay, so we've got the freaking singularity, we've got virtual threads, we've got a web app babysitting a database, moving quickly, making changes, life is good, git clone run, Docker compose, good stuff. I think it's time to think about production. And here, friends, there's some concerns. How do I most optimize my application? How do I package my application? Etc. When it comes to Docker containers, obviously the answer is, and has always been, to use build packs, right? So build packs are a great way to containerize your applications. Very, very simple. There's even support in the Spring Boot plugin, so Maven Spring Boot :build-image. That's fine. The next question then is, how do I package the application so that it's more efficient, more performant? And friends, here I want to stress that I think that Java is already very, very, very efficient and very, very interesting. This is no more better embodied than by this blog from the New Stack from 2018 BC, or before COVID. And this blog asks the question, which programming languages use the least electricity? And there's a number of great results here, but I love this table right here. Let's take a look at this table. So we can see this is the normalized global results for energy, time, and memory. And obviously in this list, C is the most efficient for machines. Very important to stress that. Not for people. For machines, C is the most efficient language. Okay? Good. We've got Rust, zero cost abstractions, doing quite well. Good job. You got C++, disgusting. Moving on. Moving on. Then you got Ada, okay, great, nobody cares, and then Java. And Java, let's just round up, my friends. Let's say that Java is 2.0, okay? Simple math. I have a very smooth brain. I need simple math. So 2.0, round up, twice as inefficient as C, or C is twice as efficient as Java. Everybody with me so far? Great, moving on. Going down, you got this list here. You got other languages. You've got, let's see, you got Swift. So if you, like I, are using Apple kit, then you've got Swift somewhere. I've got an iPad, I've got a laptop, I've got a phone that keeps ringing. Like, that's Swift everywhere. Okay, good stuff. Moving on. Haskell, you got C#, you got Go, Away, you've got, let's see, you've got these disgusting languages, the less said about which the better. I don't understand this. How is JavaScript 4 or 5 times worse than TypeScript? I thought one compiled into the other. This is a bad result, especially given that TypeScript adds types. It should make the compiler easier and more thoughtful and concise, you know? This is an incredibly bad result. If you, like me, are using the safety blanket of TypeScript to sleep at night, if you, like me, are using TypeScript because you want to feel like something is going to be okay, then you and I are in the same boat. And our boat is sinking. Just very, very sad. Then we have TUI. Moving on. I don't even, why? Continue. And then we have this, friends. We have JRuby and Ruby, and these numbers I think are incredible. JRuby is Ruby in C, in Java. And then Ruby is Ruby in C. The JRuby version, the Java version of Ruby, is almost a third more efficient than the C version. That's because the JVM is boss sauce software. It's awesome. Never ever let anybody tear it asunder. And then you got that. And this really makes me sad because I love Python. I have been using Python since Bill Clinton was president. Right? I'm a big fan, but this is not a good result. 76. Let's just round up, okay? 76. So round up 76. What is what did we say? 76. The other one was 2, right? I'm not very good at math. You know who is good at math? Freaking Python. So let's do that. 76 divided by 2, 38. That means that if I wrote a program in Java, and that program resulted in a little bit of energy being created, and that energy, the creation of the energy released a little bit of heat into the atmosphere, and that atmosphere warmed up just so much as to kill 1 tree. Then the equivalent program in Python would kill 38 trees. That's a forest. That's worse than Bitcoin. We need to have a conversation about this, especially with the rise of Python and everything. This is not acceptable. I forgot what we were talking about. Oh, right, Java. Java's great, okay? It's really, really good is what I'm trying to say here, friends. Really, really amazing results. So when I say what I'm about to say, bear in mind, I think it's amazing, but I think we could also do better. It is so amazing for 2 reasons, right? The first reason that it's amazing, obviously, is the Java programming language garbage collector. The Java programming language garbage collector is phenomenal, right? The Java programming language garbage collector allows me to sort of write mediocre code and, get away with it, right? I'm a big fan. The Java programming language garbage collector, that said, is, I do take issue with the notion that it is the original garbage collector, right? I think that honor probably belongs to this person. Her name is Jesslyn. She works at, I guess she's at Meta, which is a startup in California. They do a website that destroys democracy. Let's see. So she is from the island of Java, Indonesia. And she is the Java garbage collector. She is the original. Surely. Java garbage collector. And by the way, what I love about this, that's the Venn diagram of people who care about Java programming language garbage collection, actual garbage collection, Indonesia, and all that, and then on the internet, no less, the group there's like 19,000 people. The internet is a cesspool most of the time. This is the one exception. Good quality humor right there. Okay, that's part 1. Part 2 is the just-in-time compiler. The just-in-time compiler is another reason why the Java language is so amazing. It takes your dynamic code, dynamically executed code, and it finds parts that can be optimized into native code, and it does so in such a way as to produce operating system and architecture-specific native code. It struggles, however, with dynamic things like reflection, serialization, JDK proxies, JNI, etc. But that said, it does a pretty good result. Just look at what we saw with JRuby, right? It does a really good result most of the time. And so the question then is, well, if it's so good, why couldn't I just turn the whole program into native code? Why couldn't I just proactively optimize the whole thing into native code? And yeah, that's an option, right? We have OpenJDK, we have GraalVM, right? How many of you have heard of GraalVM? It's an OpenJDK distribution with some extra niceties, including a native image compiler. The problem is, in order to use it, you have to tell it about all the dynamic things I just told you about, like reflection, JNI, serialization, JDK proxies, resource loading, right? All this kind of dynamic stuff. You have to tell it about all these dynamic things. And you have to do that by providing a JSON configuration file. I have two problems with this. First, I hate saying the word JSON. It just sounds stupid. I cannot believe adults say that to each other. Did you create the JSON file? Stop it. I speak French. In French, you would say a JSON, which is much cooler. But I was in Taiwan recently, and there they have a language, Hokkien, and they have the word Jingsong, which means happiness, which I appreciate. So either way, pick your team. I am definitely not JSON. This one or this one, either one, whatever. I'm team JSON, but it doesn't matter. That's the first thing. Second thing is, there's just a lot of it required. There's just a lot. Somebody's got to write all this JSON. And I don't have the time for that. I don't even have the time to finish this talk. Why would I bother? No, instead I'm going to let the Spring AOT engine do that work for me. So we'll go back to the command line here. Terminal, Gradle W. Oh, I got rid of that, didn't I? Maven W, Spring boot colon native. I don't know what I'm doing. Native compile. I've completely forgotten. Okay, and then skip test because I didn't write any tests. Okay, we'll let that do its thing in the background. It's going to compile. This is the only problem with the GraalVM compilation is that it just takes an exceedingly long time, and I don't like it. It gets very frustrating, right? I sit there waiting for the response. I just get bored. Do you ever just sit there and it's long enough that you don't have enough time? It's long enough that you kind of get stuck, but it's not long enough that you can do something useful, like go make a cup of coffee or take a walk or whatever, And so I just sit there. I just end up like staring at the ceiling, trying to stretch my eyes out. Maybe I'll take, I'll stare out the window or something. And I get very bored. And frankly, I finally understand this XKCD cartoon. I didn't want to understand this XKCD cartoon, but I get it now. It posits that the number one program excuse for legitimately slacking off, my code is compiling. I thought that was the C++ people. I didn't know it was us. This is a new thing for me, right? So here we are in 2024. Now I'm sitting here waiting for my compiler. This is not a thing I'd ever thought I'd have to do. I left C++ for a reason. So yeah, I get that now. I get it. I don't want to get it, but I do. And it's problematic because I get really bored easily. You can imagine, nobody likes to sit there and wait, and your mind wanders, especially as you do these long compilations. And I start to hum music, or I hear theme songs in my head, and eventually I hear elevator music. I hear it in my head, and I start to hum those theme songs. So I thought, wouldn't it be great if everybody could hear elevator music? So I went to Oracle. And I said, Oracle, please play elevator music during the native image compilation process. I said, I already hear elevator music in my head when I do these sometimes long-running compilations. I'd just like everybody else to hear it too. Thank you in advance, and I appreciate your work. And by the way, I do appreciate their amazing work. They're doing great things over there at Oracle. And I said, and I got some great responses, including this one from Andrew Din, a distinguished engineer on the Red Hat Java team, OpenJDK reviewer and a Byteman project lead. Clearly a good use of his time. He said, please, can you make it this elevator music? And I'm not going to play it because I think it's like copyright or whatever. It's the Nintendo 64 video game for the GoldenEye James Bond movie. There's a soundtrack, so it's like 3 levels from the actual property, and it's got a elevator music. It's properly great. I would add that using beeps in general, not only for native image, really helped me to reduce development time. True. This makes a lot of sense. My stupid microwave will make a ding sound. Why can't my multi-million line compiler? And then I got this one from another one of my favorite doctors, Dr. Fabio Niephaus on the GraalVM team. He's a researcher. And he says, thank you for your feature request, Josh. The problem with playing music during the compilation process is that it's just fixing the symptoms, and we've been and are still working on the cause, making Graalvm native images more efficient in terms of time, memory, and CPU consumption. Go on. Anyway, I have prototyped the -- Josh Long mode. So what this would do is you would run the native image compiler, which is what that Spring Boot plugin is doing behind the scenes. You'd pass in -- Josh Long mode. You'd hear music. That's the whole point, people. Don't let the fact that this is an image preclude you from hearing the music. But you're wondering, why am I hearing music? So then it prints out music brought to you by Josh Long. Okay, now I know who to thank. But you're still bored. The music's helping, but you want something to look at. So then that, right? You'll just print that out. And I think that's going to be, I'm sure it'll get merged soon, very soon. I'm waiting for that. What were we talking about? Oh, the compilation, right. Let's see. Oh, yeah, that finished several minutes ago. That's awkward. Okay, so target. Here we are. du -hs, that's the service. Service, here we go. Service, whoop, there we go, run that. Port blocked. Okay, let's stop the existing instance. Fine. Go here. Go back to this. Boom, there we go. So there's our application. About 100 milliseconds, 1/10 of a second, 100,000th of a second. There's our virtual threads. And of course, we go back to, where do we start? Here. Let me just get the customers for want of time. Et voila, there we go. My friends, we just did a thing. Who learned something new? Who had some fun? Very good, I'm glad to hear. I cannot stress this enough. There's never been a better time to be a Java and Spring Boot developer. I hope I've so persuaded you. Thank you so much for your time. Have a wonderful, wonderful day.